So today I'll be talking about subject and object in science and mysticism. The mystical view of reality is that consciousness is what is ultimately real. In contrast to that, the common sense and scientific view of reality is that the objective world is what's ultimately real. Each of these provides a different approach to investigating and understanding what this is all about and inquiring into it. And one of the purposes or missions of the center is to look at these two different approaches and see how they might be compatible with each other and provide a worldview in which we can see that there are different approaches to understanding the same underlying reality. So are these compatible, and how can we maybe see whether they're compatible? And what happens with each of these approaches when they're taken to their ultimate end? So we'll start with the path of subjectivity, and we'll look into that, how it defines reality, and how we can investigate experience from that perspective. And then we'll look at the scientific and common sense view of reality, which is that the objects are what is real, and we'll look at how that investigates and analyzes reality. And we'll see maybe what they have in common with each other, maybe how they differ from each other, and see maybe where each of them goes if you take them all the way to the end of the inquiry. So the path of subjectivity, the mystical path. The mystics define reality as in terms of the subject, in terms of consciousness, and regards objects as secondary or unreal. So just to give you a few examples, the center has 5 fundamentals of our teachings here. And the first one is that consciousness alone is absolutely real. The appearance of an objective world distinguishable from a subjective self is but the imaginary form in which consciousness perfectly realizes itself. One of Joel's teachers, Franklin Merrill Wolff, developed a philosophy, a transcendental mystical philosophy, and the first fundamental of his philosophy is that consciousness is original, self-existent, and constitutive of all things. In the Tibetan tradition, Padmasambhava says, apart from the mind, there's nothing else. Huang Po, Zen Buddhist, says every single thing is just one mind. And in the Hindu tradition, Ramana Maharshi says the self is the only reality. And the self here isn't our little self in this body running around in an objective world, but the transcendental self, the consciousness itself. So this is how the mystics define reality. And then they proceed based on this definition to investigate experience in terms of that definition and analyze it and see what is real and what isn't. So the path that this follows is based on this principle of discrimination. And this is what I'll be describing today is really more of the jnana path. There are lots of different ways to talk about mystical paths and lots of different teachings. What I'll be emphasizing today is more the path of inquiry, the path of knowledge, which has maybe closer parallels to the scientific path that I'll be talking about later. So that's why I'll be emphasizing this, but there are lots of other ways to look at the path and teachings of devotion and so on. So don't mean to exclude those. So the path of inquiry proceeds by discrimination between what is real and what is unreal, between what is subjective and what is objective. So where is this distinction? And the practice of discrimination is to stop confusing these two. Because when we confuse or conflate what is subjective or real with what is objective or unreal, according to this perspective, we suffer. So, for example, if we confuse consciousness itself with bodily objects, such as our own body, then when the body dies, well, then we'll have lots of fear around that. Shankara says, reality is attained through discrimination. Brahman is real, the universe is unreal. A firm conviction that this is so is called discrimination between the eternal and non-eternal. So there he brings in another quality or attribute by which we can distinguish between subject and object, or real and unreal, is that the subject is eternal and the objects are non-eternal or ephemeral or impermanent. There's variation and there's the invariant. So the universe of objects is what varies, changes, it's impermanent, it comes and goes, whereas the subject or self, the reality, is what's impermanent or invariant. The other difference or key that can be used in the process of discrimination is that what is real is what is known immediately in our consciousness, as opposed to what might be hypothetically known or known only conceptually or perceptually as objects. And this process of discrimination proceeds in the path normally from examining gross objects, and then it gets subtler and subtler and gets refined and refined and refined more and more and more. So let's step through this process and kind of get a feel for how it goes. So we start with what we take in our common sense to be consciousness. For example, consciousness is something that people have. That's sort of the common sense view of you're conscious, I'm conscious, those other people are conscious, maybe animals are conscious. So this is a view that we can then examine using this principle of discrimination. So we can notice that, well, people come and go. We might be aware of some other people now, and then we're not aware of them. They're gone. So they're impermanent. These bodies appear and disappear from consciousness, and consciousness remains. So we've just discriminated between what is real and unreal, according to this principle. And so that tells us that bodies don't have consciousness. Bodies aren't consciousness. So we can distinguish between those. And already we're feeling a little bit uncomfortable. Wait a minute, all these people don't have consciousness? So that's something to sit with for a while and practice, is that discrimination. And then we say, okay, well, fine. This might feel a little bit like solipsism, but let's just go with it. What about my consciousness, right? Okay, well, that's obviously associated with my body. Well, let's examine that using the principle of discrimination. And then we begin to notice that, well, what is our body? Well, we have all these sensations of our arms and our legs and inner sensations and so on. And those all come and go. So we see this most dramatically when we fall asleep. Whole body just drops completely out of awareness. And we'll start dreaming, and maybe a totally different body might appear in awareness. And sometimes you might have a disembodied dream where there really isn't a sense of a physical body at all. Yet there's consciousness. So we can discriminate now between what comes and goes and what doesn't, and determine that, well, what's real is the consciousness and what's unreal is the body, even our own bodies. So now we've reached a point where we're maybe even more uncomfortable. Because, well, if consciousness isn't associated with even my body or anyone else's body, well, what is it? And incidentally, another way to analyze this is we might think, well, sure, my body isn't any one sensation or another, but there's still this idea that there is a body even when I'm asleep. But if you use the principle that what we know is real is what is immediately present in awareness, and you look for this thing called a body, can you find it? Is there such a thing as an objectively existing body that we can immediately know? When you look at what's immediately present in awareness, you see these sensations arising of sights and feelings and smells and so on. And you might even see a thought arising, oh, well, that's a sensation of my hand, for example, or that's a sensation in my foot, and that's part of my body, but that itself is a thought that arises and it can pass away as well. So that idea of there being a body is really a kind of conceptual model that we have, that we use to kind of orient ourselves within the coming and going of all these different kinds of sensations. And some of them we might call our bodies, and others we don't. And so that's really a concept or a model that we use to understand all of these sensations that come and go. But that model itself isn't something permanent in awareness either, as the example of the dream shows as well. So even that idea of the body isn't something that satisfies this definition of reality, according to the mystics. So that's how the discrimination starts, and then it gets to a more subtle layer. Well, if consciousness isn't something that my body really has, maybe it's something my mind has, or my brain. Well, you might look to see if you've ever directly experienced your brain in awareness. I haven't. I don't think I've directly experienced any brain. I might have seen a video of maybe brain surgery or something, and I've seen some gray matter that my conceptual model has categorized as something that we associate with an objective thing called a brain. But that visual image itself isn't a brain. It's a visual image, and I could be mistaken about it, actually. It could be just some kind of virtual reality thing, and there's no real brain behind it. So we never actually experience some real brain apart from just our thoughts and sensations that arise and come and go. Well, maybe it's maybe consciousness is somehow something not physical, but something kind of going on in mentally, in some sort of mental realm, some subtle realm that isn't physical. Well, then we can look at, well, what is going on, setting aside ideas about whether it arises from the brain or not. What is this mental realm, and what are the phenomena there? So we apply discrimination again, and we see mental phenomena arising. It could be thoughts, images, memories, all sorts of different phenomena that come and go in our mental field. And just like the body, this idea of a mind is a kind of model that we use to understand these mental phenomena and categorize them. Oh, well, this is my thought, this is my feeling, and this is my memory. And some people can have experiences where that they have inner images or thoughts that they don't associate with themselves, with their mind. For example, someone who with multiple personality disorder or all sorts of different states of consciousness. Don't necessarily categorize mental phenomena as necessarily belonging to my mind. There could be other mental phenomena that are outside of our definition of our own mind. And just like the body, that idea of the mind is just really a thought or a category that we use to organize these phenomena that come up in the mind, and it itself is something that isn't permanent. And we never directly experience that as something in awareness, apart from the thought, which comes and goes. So using discrimination again, we see that according to the definition of reality and unreality, that is all unreal. It's impermanent. It comes and goes. And what is real is what is invariant to experience. And that's the awareness itself. So discrimination takes us from discriminating between the self and the body, discriminating between the self or subject and all mental phenomena. And then it gets to the point where it has really discriminated between the self or consciousness itself and all objects that arise whatsoever. And this is what we might call the transcendental level, where it's kind of transcended all objects altogether. And there might be just this sense of the subject as just a non-local awareness or witness of everything that arises in awareness. And it doesn't have any location in space, because locations are things that bodies have. It doesn't have any location in time, because location and time are things that bodies and mental phenomena have, this sense of a stream of things succeeding each other. That again is a way of organizing these phenomena into a succession. Just like the idea of a mind or the idea of a body, this idea of things succeeding each other is also an idea, a way of classifying and organizing these phenomena that are coming and going. And this pure subjectivity transcends that and discriminates. If discrimination is applied, it discriminates itself from all of those phenomena as well. So this is where it reaches near the culmination of this process of discriminating between subject and object, where there's this pure witness or principle of subjectivity and just this phenomena that arises and passes within this field of awareness. Here's what Shankara says about this stage. He says, "One who seeks liberation from bondage must discriminate between Atman and non-Atman." That's the self and non-self. "One must separate this Atman from every object of experience. Then he must dissolve into the Atman all those appearances which make up the world of name and form." So at this kind of final stage, once discrimination has separated, purified all of experience of this confusion between subject and object, there's perhaps this final lingering, very subtle distinction in consciousness between that pure subject and just the phenomena that are arising and passing within awareness itself. And then there's the opportunity to investigate whether those appearances are different from the awareness of the appearances. Is there really a distinction there? And the mystics all testify that it's possible to realize and recognize that there is no distinction. The phenomena themselves are no different from that empty space of awareness that witnesses them. So the form is emptiness and the emptiness is form. The distinction between the real and the unreal, the subject and the object, collapses at this point. Atmananda from the Hindu tradition says, "Objectivity in any form is the only obstacle to truth. If you transcend it, the subjectivity also naturally disappears, and you stand as the reality yourself. And Shankara echoes that. Thus, the wise one reaches that highest state in which consciousness of subject and object is dissolved away, and the infinite unitary consciousness alone remains. So that's the path of subjectivity. Now let's switch gears entirely and look at how the path of objectivity views reality and how that proceeds. And we'll see maybe what they have in common, how they differ, and whether they end up in the same place in the end or different places. So the path of objectivity defines reality in terms of objects instead of the subject or consciousness. Here's what Einstein says. Physics is an attempt conceptually to grasp reality as it is thought independently of its being observed. In this sense, one speaks of physical reality. And elsewhere he says, the belief in an external world independent of the perceiving subject is the basis of all natural science. So the way science, and this really comports with common sense as well, our common sense view is that these objects are out there, and independent of whether you actually see this or not, you still think it's there. And it comes back and it goes, and this is one of the first things that infants learn is object constancy. It's fun to play peekaboo until you realize that, well, it isn't really gone, and it's not a surprise anymore, right? So that's the sense that things continue to exist despite them not being perceived anymore. There's this idea of it. They're still out there. And the other aspect of this that we use to distinguish between objectively real things in the world and subjective things is the idea that objective things shouldn't depend on our preferences, our opinions, our beliefs, our interpretations, our biases, and so on. And we should be able to test them or prove them and confirm them. So if something's real, you should be able to verify it's real too. If I say, well, that's objectively real, that's an objective fact, then you should be able to go and check it out and see for yourself if what I'm saying is correct or not. Now what's interesting is we can see that the path of investigating reality in terms of objectivity also is based on this principle of discrimination between subject and object. But it's starting with a totally different definition of what is real. And it also shifts the definition of subject and object a little bit too. Well, more than a little bit. The subject in this view has more to do with what we call the empirical subject or the personal subject, the things that are associated with different individual human beings. So we all have our own idiosyncrasies, our own biases and preferences, and these may change what we think. Oh, it's too hot in this room. That's not an objective statement because it depends on my personal preferences of what is too hot, what is uncomfortable and what isn't. It may depend on how I'm clothed. It may depend on whether I'm nervous or not. It may depend on lots of things that are unique to me. And another person may say, well, it's not too hot at all in here. So what we can do is go look at the thermostat in the back of the room, and it gives us a number, and we can all agree on what that number is displaying on the thermostat. Now, whether that particular temperature is uncomfortable to us or not still may be the case, but now we've discriminated between what is an objective fact and what is just an expression of some subjective personal preference. So there's this principle of discrimination is coming in, where we need to clearly discriminate between those things that are dependent upon all of our own personal idiosyncrasies and those that aren't. And it's very useful practically to know what are the facts and what aren't the facts. It's useful to know when we should plant seeds in the ground. Is it spring or is it fall? If you plant your seeds in the fall, it's not going to work out so well. It's useful to know whether that particular berry on that type of bush is poisonous or not. Those kinds of things are very useful to know. And so it's not going to depend on your opinion of the bush, whether you like it or not, or whether it is the kind of bush that pleases you. If you eat that berry, you're going to get sick or not. So the path of objectivity is to discriminate between subject and object, real and unreal, according to these definitions and ways of discriminating. And this is well recognized in science, that this is what science is really about doing, is making this discrimination between subject and object very clear. So here's what Niels Bohr says. He's one of the founders of quantum mechanics. The whole conceptual structure of classical physics rests on the assumption, well adapted to our daily experience of physical phenomena, that it is possible to discriminate between the behavior of material objects and the question of their observation. And David Bohm, another quantum physicist, says, if a sharp distinction could not be made between the observer and the systems observed, scientific research as we know it could not be carried out, because the observer would not know which aspects of an observation originated in himself and which originated outside in the system of interest. So the whole point is to tease apart the properties of a system we're investigating that depend on how we're looking at it, and the parts that are inherent to the system itself. This is the whole way in which science operates and tries to discriminate subject and object in order to proceed with this kind of objective knowledge of the world. Max Planck, the grandfather of quantum mechanics, says the first and most important quality of all scientific ways of thinking must be the clear distinction between outer object of observation and the subjective nature of the observer. Now, one way of looking at this is to say that the objective features are those that have this property of invariance. And the invariance is the invariance with respect to different observers. So if a property depends on who's looking at the object, then it's a subjective property. If the property doesn't depend on who's looking at it or how it's being observed, then it's an objective property. So the idea is to find those properties that are invariant with respect to changes in observation or changes in observer. So that's one of the principles that science uses to discriminate between subject and object. And there's actually a commonality here with the subjective approach, is that also, remember, defines what is real in terms of what is invariant, what is eternal, what doesn't change. So there's one point, at least, of commonality here. So this investigation of the world in terms of objectivity as being real also proceeds from the gross to the subtle. So let's step through some of those stages and see how it goes. So in our naive, realistic way of experiencing the world, there's the appearances of objects, and as the objects move around in space, the visual appearance changes. And so discriminating using objectivity, we know that it's not the visual appearance that is real, it's something else that's real. And so the common sense view and the scientific view would be that what's real here isn't the appearance, which can vary depending on who's looking at it or how the object is oriented, but the properties such as the length and the width and the thickness of an object. And you can determine those using well-defined methods of measurement, for example. But that length and width and thickness isn't something that we directly experience. It's this kind of model that we have of objective properties independent of observation. So it's really a kind of abstract model that we consider to be real. Simone Weil says, the application of this rule for the discrimination between real and illusory, in our sense perceptions, if we are not sure of what we see, we change our position while looking, and what is real becomes evident. She doesn't mean real here, by the way, in an absolute sense. She's just talking about ordinary sense of reality of objects. So if this can also be very useful for us, and for example, in commerce, when people used to, before money was as developed as it is now with bitcoins and so on, people exchanged things like gold coins, and if you could create like a counterfeit gold coin that wasn't as heavy as all the other gold coins, and the way you could tell the difference is whether it's the same size and whether it's the same weight. Well, if you just put it in your hand, oh yeah, that feels about right. Someone else might say, well, actually, I don't agree with you. I think that's not right. So these people might disagree about whether you've actually paid them in enough gold coins or not. And the way that settled is to develop like scales. And so people in commerce started actually weighing things. And you would put some kind of standard weight on one side and then put your product on the other side, the flour or whatever you're buying or selling. And there would be standard ways to measure these things, just like we use a thermometer to decide what the temperature in a room is. There's another fun, optical illusions also illustrate this, where our subjective perception of things can mislead us and actually make us mistake what is objectively real and what isn't. So here's what's called the checker shadow illusion. And this is a little small, but I can pass this around later. This is a picture of a checkerboard of light and dark squares. And there's also a cylinder sitting on the board, and it's illuminated from the side. And you can see the cylinder is casting a shadow on the board. And you can see the squares are alternately colored light and dark. And if you look at this square up here, this is obviously one of the dark squares. And this square down here is obviously one of the light squares. And I'm pretty sure any one of you would confidently say that this square is lighter than that square. But if you cover up everything else except those two squares, you see that they're actually, objectively, they're the same shade. But our perception deceives us when we see them in this context. And so this is a way to kind of remove that subjective element from our perception and find something objective. If you took some kind of device that measured the lightness of something and you put it over A and put it over B, you get the same measurement. And so that would be an objective measurement. Whereas just looking at something, we can be tricked and our perception can delude us. Yeah. So I'll pass this around. You can.
There's also the cylinder.
Yeah.
It's hard to tell whether it's solid or hollow.
Oh, I never noticed that. So there are lots of ways to illustrate this as well with other things. Just as one person might say this room is too hot, another person say it's too cold, and the objective measurement is determined by measuring with a standardized thermometer. And that's how we distinguish between subjective and objective. Someone might say there's a lot of people here today, but that depends on what someone considers a lot to be. If I say, well, there's at least 100 people here today in the audience. I'm glad I brought in such a great crowd on this sunny day. Well, we can verify that, of course, by counting the number of people here. And assuming we all use the same conventions for counting, we'll all end up with the same number, and there will be an objective fact of the matter that we can all agree on. Now, what science does is it starts to refine this process and recognize that what's really critical and important here is that these processes we use to make these observations need to be standardized. Because even if we use something like a thermometer, if you're using a thermometer in Fahrenheit and I'm using one in Celsius, we're not going to get the same number. If they're not properly calibrated, they may not agree either, even if they're both Fahrenheit. So it's very important to standardize these things. If we want to measure the width of this room, we don't have a ruler handy, so we just measure how many paces it is across. And I might measure the number of paces to be, say, 20. Barb might measure it to be 30. And so what is the length of the room? Well, it's 20 paces or 30 paces. Well, we obviously have paces that are different sizes. So in order to standardize, in order to get an objective result for our measurement, we need to standardize our measurement unit and say, okay, we're all going to use this length for a pace. You know, it used to be that a foot was the length of the king's foot or something like that. But then eventually people said, well, the king's foot, you know, how big is that exactly? And it's going to change, right? So they need to standardize a foot. And someone, I think there was a statue or something somewhere where someone etched the size of a foot into a metal plate or something, and then that would stay still. But actually, it turns out metal plates expand and contract slightly in temperature, right? And so you have to compensate. And so science refines and refines and refines things more and more and more to isolate what is independent of all other kinds of factors and to find out what is objective. And the end result of this process is quite interesting if we follow it. Arthur Eddington, a physicist in the early 20th century, said, "The standard specification of the procedure of observing must be sufficiently detailed to secure a unique result of the observation. It is the duty of the observer to secure that all attendant circumstances which can affect the result are in accordance with the specification." So that's kind of a highfalutin, fancy way of expressing what I was just trying to explain. So making a measurement requires a reliable observer reliable measurement devices that are calibrated, that are standardized, that are using specific units that you can trace back to some standard that everyone's using. And if you don't do that, you can get all sorts of inconsistent results, and you won't have this kind of invariance with respect to different observers or different measurements. Wolfgang Pauli said, the instrument of observation, which we call the subject in this context, must possess a higher degree of stability than the system being observed, which is the object in this context. So what we start to see here is that in order to get objectivity in the world, we need to specify and fix our way of observing the world. So our methods of observing the world. If we change all of our different methods of observing the world, don't use the same units or aren't consistent about them, we won't get consistent or objective results. So we begin to sense something interesting here, that the objective world really rises in dependence upon our desire to get objective results that are invariant. And our desire to get those objective results results in us saying, well, in order to get objective results, we need to fix the manner in which we observe things so that it's very stable and that we can ensure that we don't get measurement results that are going to depend on changes in our measurement device. So we have to get stable measurement devices in order to get stable measurement results. And so what we see here is that the objectivity, even in science, depends on the subjectivity. And the invariance in the objective world is only stable insofar as we contrive things or define things or adopt conventions so that our manner of observing them is stable. Now things get a little more interesting as science progresses even farther and in this process of seeking objectivity or invariance. It was discovered by Einstein in his theory of special relativity that intervals in space, spatial separation between things like length, isn't objective. It depends on the reference frame that we choose to observe it. And the same with temporal intervals or durations of time. So for example, imagine a 10 or 100 meter long train that pulls up into a train station, and the train's platform is also 100 meters long, so that the very front of the train matches the end of the platform and the very back of the train lines up perfectly with the other end of the platform. So they're both 100 meters long, and that, we would say, is an objective fact. And in classical physics, you would also say that, well, it doesn't matter if the train is moving or not. If it's moving, it's still 100 meters long. But in relativity, that's not the case. If we have a train that goes super fast, I'm not talking a TGV here, I'm talking about like 80% the speed of light, then that 100-meter train will actually be 60 meters long from the perspective of the platform. Now, of course, if you're on such a train, the train will be 100 meters long, but the platform will be 60 meters long. So what is 100 meters and what is 60 meters depends upon the frame of reference that's chosen. So it's not an objective fact anymore. It depends on the perspective or reference frame from which it's viewed. So length is no longer an objective fact. And the same happens with time, by the way. The time, the duration in which things happens dilates as things move quickly. Now, what is objective then if our time and space distances aren't objective anymore? What is objective? Well, in special relativity, at least in that context, there is something that is objective or invariant with respect to all reference frames. And that's what's called a space-time interval. And that's a particular number you can calculate that depends on the separation in time and the separation in space. And you combine those in a certain way and you get this number, and all observers will agree on those numbers. They'll measure the distance, the length of something, and they'll measure the time. And the way those are combined in this formula, they'll all get the same number. Even though one observer has a different length, they'll also have a different time. And the way these fit together in the formula, you'll come out with the same number for everyone. So it's a very crude analogy. It's like 1/3 is equal to 2/6. You have these different ratios, but it all comes out to be the same. So this is interesting here because what science considers objective now is not, it's departing more and more from our common sense notion of what is objectively real. Now it's this, instead of a three-dimensional space and a one-dimensional time that are absolute and fixed, there's this four-dimensional space-time continuum, and that's fixed and objective, and some objective properties within that four-dimensional space-time continuum are this interval I was talking about. So this becomes very abstract now, or you might say subtle. The objective reality becomes more subtle, more removed from our common sense ideas of what's objective and what's not. So the sense of what is real and what isn't has shifted. And this may seem odd, but there's an interesting analogy that we're all very familiar with and most people have no problem accepting. We normally say that the sun rises and the sun sets, right? In the morning, the sun comes up and the sun goes down. Our language still talks about it in those terms as if the earth were at rest and the sun were moving across the sky. And this indeed was the cosmology for a couple thousand years in the West, the system of Ptolemy, where the geocentric view was that the earth was at rest in the center of the universe, and the sun moved around the earth once every day. And so we naturally say that the sun rises and the sun sets. And this certainly makes sense because we don't really feel ourselves moving on the earth. The earth seems to be still. And it's pretty clear that relative to that anyway, the sun is what's moving. So that accords with common sense. But then Copernicus came along and said, well, it actually makes more sense scientifically to regard the sun as being at rest in the solar system and all the planets, including Earth, going around it. And while it's doing this, the Earth is spinning. And it spins once a day on its axis, and that's why we seem to see the sun as rising and setting. It's not actually rising and setting. It's still, and we are spinning around. So what's interesting about this is the notion of what is real and what is apparent has changed completely. What was real initially was that the earth was at rest and the sun was moving, and now suddenly it's the opposite. The sun is at rest and the earth is moving. So as science evolves, this notion of what is real, what is objectively real and what isn't, shifts. And Einstein took this one step further and said, well, actually, neither of those is real. There is no such thing as absolute rest or absolute motion in the universe. It's all relative, so that there's no... it's just as valid to say that the earth is at rest as it is to say that the sun is at rest. Those are just two perspectives on the situation, you might say. Here's what Einstein says. Either coordinate system, meaning the geocentric or heliocentric, could be used with equal justification. The two sentences, the sun is at rest and the earth moves, or the sun moves and the earth is at rest, would simply mean two different conventions concerning two different coordinate systems. So these are just ways of describing things from different perspectives. And what's objective is something deeper, more subtle. This four-dimensional space-time continuum thing. It gets even worse with quantum mechanics. In quantum mechanics, particles, like an electron, they don't have a well-defined position or momentum independent of the specification of some measurement apparatus. So if you set up an apparatus to measure position, then you can talk about the electron as potentially having some position, but then you just have to say, we don't know what its momentum is doing. Conversely, you could set up another apparatus to measure its momentum, and then you can talk about what its momentum is, but then you have to say, well, there's no real position we can talk about here. These are called complementary physical observables. Here's how Niels Bohr puts it. It is indeed more appropriate to use the word phenomena, here he means an objective phenomena, to refer only to observations obtained under circumstances whose description includes an account of the whole experimental arrangement. So the properties like position and momentum aren't objective properties anymore. They aren't, it's not like the electron has a position and we just don't know it yet. It actually has an indefinite position and momentum. And the Heisenberg uncertainty principle states that you can't know either of those perfectly, precisely, and you can't measure them both precisely at the same time. So they don't actually have definite values independent of measurement. And to make matters worse, what's described, the way quantum mechanics describes the state of an electron when we're not observing it, independent of observation, what's objective about these electrons is not a position or a momentum, but a probability. So it just talks about the probability of having a position or the probability of having a momentum. Bohr says, an independent reality in the ordinary physical sense can neither be ascribed to the phenomena nor to the agencies of observation. So what's objective is this wave function that doesn't say the particle has a particular position or momentum. It's just this wave of probability. And what's worse is that this isn't like a water wave a water wave is easy to intuitively grasp because there's this water. We know what water is. It's just liquid and it moves up and down. And there's something there that's moving, and we describe it in terms of the height of each wave going up and down and so on. With these probability waves, what is it that's waving? It's not some substance, it's probability, this abstract thing. So it's not some physical thing that's waving here, it's this probability wave. And even worse, it doesn't live in three-dimensional space. It lives in this infinite dimensional space called Hilbert space. And each dimension isn't even a real number. You know, in normal Cartesian coordinates, you have a number, and it's a real number that you measure from the origin. Okay, each point has a distance x and a distance y, and you measure it, and it's a real number. In this space, each coordinate isn't even a real number. It's a complex number which involves imaginary values, the square root of -1. So you've got this infinite dimensional space whose coordinates are these complex numbers with imaginary values, and it's describing a probability. And this is what's objective.
Of course.
So we're getting more and more and more subtle and further removed from our ordinary conception of what is objectively real, following the methods of science. So how do we understand this crazy description of the world according to science? Well, there are many different interpretations of quantum mechanics. Everyone agrees, all the scientists agree on the mathematics of it. There's no doubt there. And if you take the mathematics and you solve it for a particular system, like a semiconductor, you can predict exactly how the electrons will behave if you apply a certain voltage, and you can build semiconductor chips that do all these amazing things in all of our portable devices and so on. It's all based on quantum mechanics, and it works perfectly well. There's no disagreement about that. There's no question that it works. But the question has to do with how we can try and understand what kind of world is quantum mechanics describing. How can we understand this? So there are these different interpretations that take a stab at trying to make sense of the world that quantum mechanics is describing. Look at the mathematics and say, what kind of a world is this describing? In classical physics, it was kind of easy because you had these objects, they were points in three-dimensional space, and they moved through three-dimensional space as they moved through time, and it all kind of matched up with our intuitive ideas of space and time and objects moving around. But here we've got this infinite dimensional Hilbert space and probabilities and all of this, and how do you make sense of this as an objective reality? Well, there are different ways you can do it. There's the Copenhagen interpretation, there's the many worlds interpretation, there's the de Broglie-Bohm interpretation, there's a transactional interpretation, there's about more than a dozen different interpretations. And these are all interpretations of the same mathematics. And so they don't differ in the predictions they make. These are differences in how we understand what the mathematics is saying about some objective physical world. Well, it doesn't make any objective difference which one you choose. Those are just subjective preferences, really. One physicist can say, well, I like the Copenhagen interpretation. The other physicist can say, no, the many worlds interpretation, that's the way to go. Well, it doesn't matter. What's invariant isn't the interpretation you choose. What's invariant is what predictions the mathematics makes in terms of our measurements. And it doesn't matter how you interpret it. They both would calculate the same prediction from the mathematics. So these interpretations don't tell us objectively what is being described here. So we're left just baffled, really, with nothing but the mathematics to rely on. So this hints at something quite remarkable, and that's that, well, maybe we've been kind of mistaken all along, trying to even understand this physical world in terms of objects existing physically out there. Maybe it's really more mathematical in nature, which is more of a mental type of thing. And so what is objective is the mathematics. That's what's invariant. That's what all the physicists will agree on, not the interpretation trying to understand some sort of physical, ontological objects existing out there. And the laws are invariant they're common to all the measurements. All the measurements will agree with the laws. They're invariant to all the different reference frames. This is one of the keystones of Einstein's theories of relativity, is that the laws of physics should not depend on the reference frame that you choose. That was one of the big insights he had that led him to the theory of relativity. So we have this sense of reality, objective reality in science now shifting to something even more abstract. It's not even the sense of a physical world existing out there in some sense, but more of a subtle, very subtle mathematical kind of world of objectivity. The American physicist Henry Margenau says, objectivity becomes equivalent to invariance of physical laws, not physical phenomena or observations. To achieve objectivity of basic description, the theory must confer relativity upon the domain of immediate observations. So this path of discrimination, of looking for what's invariant in science, has led us to this point where we're even giving up these ideas of physicality altogether, and we're really looking at this mathematical structure itself, which is more of a mental thing. And then we step back and we look at the history of science and we realize, well, the mathematics that has described the physical world has changed. In that sense, it's not an invariant. First we had the Ptolemaic description, which the mathematics was essentially geometry. And then Newton came along and developed classical mechanics and had certain formulas there, F equals ma and so on. And then quantum mechanics comes along and you've got the Schrödinger equation, and so the mathematics has changed throughout time. So even that is not invariant. It has changed throughout time as science has evolved. So the ultimate invariant, if we're looking for something objective, can't even be the laws of nature, at least not as we know them. So the laws of physics themselves are not invariant. They change throughout time. And so this leads us to start wondering, well, what is the objective invariant then, if it's not the laws of physics themselves? And we start looking at science and we see, well, the laws of physics really arise in the context of this scientific method, whose goal is to find these objective features of the world, and they only arise in dependence upon that kind of overarching framework of saying, okay, we're going to go out, we're going to look for things that are repeatable and invariant in experience, and here's our definition of what's objective and what's subjective. And within that framework of repeatability of experiments that can be quantitatively measured and so on and so forth, you get these corresponding ideas of what is objective. And it leads us to the point of these mathematical laws, and then we discover that, well, even those change throughout time. So what is objective if it's not the scientific laws themselves? Well, we have the framework of science itself, but it's not determining some kind of specific laws of nature. Those are laws that we need to somehow discern from our measurements, which laws are right, which ones aren't. Can't just make up any law and say it's a scientific law. It has to be tested, right? So the objective world relative to the scientific framework is very indefinite. It's like in relativity, you have all these different possibilities for the lengths you could observe. Is it 100 meters? Is it 60 meters? Each one of those depends on the perspective. In quantum mechanics, well, what's its position? What's its momentum? Well, it depends on which one you're setting up the experiment to measure. So the reality that arises objectively depends on the choice of the subjective point of view or reference that we're going to pick. And the scientific project itself is a framework that we have chosen. It hasn't been imposed upon us to investigate the world in this particular way. This is something we've chosen to do, starting way back with the desire to measure the distances between things in some standardized way that we can all agree on. And you start taking that project to its end, and you find that this objectivity becomes more and more elusive. It becomes more and more abstract and indefinite. You have what essentially is science describes all these possible worlds. These equations of physics we have don't tell us what our particular world is. It just tells us that, well, if there is a universe, it has to obey these laws. And there could be lots of different universes that obey the same laws, and somehow we happen to be in this one. That's the objective description anyway. So this leads us to really beyond the limits of science altogether, to what we might call the transcendental layer. And here we kind of enter into the philosophy of science, or philosophy generally. And Immanuel Kant, the Western philosopher, investigated what he called the necessary preconditions for the possibility of experience. And this is a kind of framework for, well, if you're going to have any experience at all, what kind of fundamental categories or structure must it have? So these are even deeper than the scientific laws at all. If you're going to have any experience at all, what kind of structure does it have to have? And he proposed that you have to have space, some kind of space. He didn't say whether it was Euclidean or non-Euclidean. He wanted to say it was Euclidean because that's what science said it was at the time. But of course we discovered otherwise. But in any case, you need some kind of space for things to happen in, and time for things to flow through. And he also said we need certain kinds of categories to even understand that there are things coming and going. You need to be able to distinguish between things, saying whether there's many or multiple or a unity or what have you. So he had these very abstract categories that he said are really necessary in order for us to even talk about experience in a meaningful way. To say that we're having an experience, to say that there is an experience, you have to presuppose that it's happening here or there or now or then, and that it's this or that. So the nature of objective experience is that there are these distinctions. And he postulated some of these fundamental ones that seem to be necessary for any kind of experience, whether it be scientific or whatever. And so this, you might say, is a even more subtle set of kind of laws or structures that must be true of any world of experience that arises. And there are many, many kinds of worlds that could arise within that framework. Some of them wouldn't be considered scientific, some of them would. So this is an even more subtle and general framework for identifying what is objective. And what is objective here is simply the space of possibility of any world like that arising, any kind of structured experience arising. And from this perspective, the kind of order we experience in the world is the result of these categories that he identified. He says, the order and regularity in the appearances which we entitle nature, we ourselves introduce. We could never find them in appearances, had we not ourselves, or the nature of our mind, originally set them there. So this echoes the idea that, well, we can't find a temperature unless we define what temperature is, what units we're selecting, how we're going to go about measuring it, and so forth. That idea of an objective temperature arises in relation to our selection of all these standards and units and so on. And the same with any experience, really. the very possibility that we have any kind of structured experience at all depends on these structures that aren't inherent in the appearances themselves. They're part of what we introduce. But these themselves aren't necessarily invariant, ultimately. You can imagine stripping them away to the point where there is an awareness, I'll call it, instead of an experience, because I'm using experience in this context specifically to mean an empirical experience, a structured experience, not just kind of immediate awareness itself. So we can imagine a mode of awareness or a mode of consciousness that is in which there aren't these structures. So the sense of time drops away. The sense of space drops away. The sense of identity and difference drops away. And these structures fall away, and there's very little that can be said about what kind of world then is objective. All one can really say is that ultimately all you can say about such a rarefied mode of awareness is that there has to be a sense of a witness to it. And Kant had a fancy highfalutin name for this. He said, there can be in us no modes of knowledge, no connection of unity of one mode of knowledge with another, without that unity of consciousness which precedes all data of intuitions, and by relation to which representation of objects is alone possible. This pure, original, unchangeable consciousness I shall name transcendental apperception. So this is the pure subject where discrimination has proceeded all the way to where we have this pure, what he called transcendental apperception, this pure witness, this pure subjective consciousness, and that's what is necessary for there to be any kind of object at all. And that's the kind of the bare minimum that is necessary to have any kind of object at all, is just this subject-object distinction. So look what's happened. We started out with this idea of looking for an objective world and identifying objective things, and we followed it through science, and we discriminated between subject and object to the point that physicality just kind of dropped away completely. We were left with more of a mental idea of what is objective, just the mathematics themselves, and then you look at that, and even that is ephemeral, variable, not ultimately invariant. That drops away. You look at, well, what's the possibility of any experience at all? You get some of these fundamental structures that Kant identified. You discriminate those away, and you are left with just pure subject and object. So if you're willing to take this project all the way past and let science drop away as well, you find remarkably that looking for invariance in objects ultimately leads you to the subject. And what science has done, most scientists have forgotten this and proceed on the assumption that just the objective world is somehow out there and exists in a physical way. And this is why there are all these conundrums about how to interpret quantum mechanics and so on. Schrödinger, who was the one who discovered the Schrödinger equation, the foundation of quantum mechanics, he was personally followed Advaita Vedanta, and he was familiar with Shankara and the teachings of Advaita Vedanta, and that was his personal view of the world. And of course he was also a physicist, and so he wrote some interesting things about physics from that perspective. One of the things he said is that without being aware of it and without being rigorously systematic about it, We exclude the subject of cognizance from the domain of nature that we endeavor to understand. We step with our own person back into the part of an onlooker who does not belong to the world, which by this very process becomes an objective world. So the objective world arises because we perform this distinction of subject and object. We imagine that somehow the subject and object are different, and that's how an objective world can arise. So he recognized this, that science itself takes place within this broader framework. And of course, the mystics have all recognized that the ultimate object is not something physical. It's not even something mental. It's a transcendental God or Brahman. And that ultimately everything we imagine to exist has its reality in that ultimate object. The Quran says there's nothing but God. And Meister Eckhart says, creatures have no real being, for their being consists in the presence of God. So, to summarize, we've looked at the subjective path, the objective path. We've looked at the different ways they start out defining what's real in terms of subject and object. The mystics start with the subject and say that's real, and then they use the principle of discrimination to follow that through subtler and subtler and subtler and subtler senses of what's real until finally the subject-object distinction collapses. And similarly, the objective approach to investigating reality starts with its definition of what is real in terms of subject and object, follows that and gets subtler and subtler and subtler and subtler until, if you allow yourself to go beyond the limits of science itself, it will take you all the way to the point where the subject and object dissolve. Shankara says, in their literal superficial meaning, Brahman, the ultimate object, and Atman, the subject, have opposite attributes. Their identity is established only when they are understood in their true significance and not in their superficial sense. So this process of discrimination is designed to reveal that. And Atmananda says both subjective and objective worlds, when they're properly analyzed, are reduced into the ultimate, which is neither subject nor object. To know this beyond all doubt and to establish one there is the direct method. Thank you.